Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at some of the applications of the derivative with our inverse trig and trig functions. So in previous videos I've talked about these applications using the derivative to find the equation of tangent and normal lines, using the derivative to solve an equation using Newton's method, doing related rates questions, which is rates of change, using derivatives to do curve sketching, and using derivatives to find maximum and minimum values of functions. So I'm going to do some of these. I won't get through them all in this video, but I do want to do the examples of these applications, but with our trig and inverse trig functions, because you're probably going to run into these types of questions. Let's take a look. In my first example, we're asked to find the equation of a line tangent to the curve y equals cosecant x at x equals pi over 4. So in order to find the equation of a line, we need the slope and we need the y-intercept. In order to find the slope, we find the derivative. So the derivative of cosecant x will be negative cosecant x cotangent x times the derivative of x, which is just 1. At the point x equals pi over 4, you might find this easier if your calculator doesn't have cosecant or cotangent functions, so write it in terms of their reciprocals. So cosecant is 1 over sine, cotangent is 1 over tangent. And if you write it like that, I think you're going to have less problems in doing the calculation. So make sure your calculator's in radian mode. When you plug all of that in and calculate, you should get negative 1.414. So that is going to be the slope of your tangent line. Remember, to find the equation of a line, we need the slope and we need the y-intercept. So in order to find the y-intercept, we need all these other values. We have slope, we have the x value. What we need is the y value when x is pi over 4. So at x equals pi over 4, y will equal cosecant of pi over 4, which will be 1 over sine of pi over 4, and that value is 1.414. Now we can use our x, y, and slope values to find our intercept. So y is 1.414. The slope is negative 1.414. X is pi over 4. So we get a value of b equal to 2.525. Therefore, the equation of my tangent line will be y equals negative 1.414x plus 2.525. Let's take a look at how we use Newton's method to solve an equation. Our next example asks us to solve the equation 4 times the sine of x plus 1 equals 3x using Newton's method. So here's the formula for Newton's method. It's a numerical method where you start with a guess, and we were given what our first guess should be. Let x1 equal 1.5, and then we plug it into this formula. So we need to know the function, and we need to know the derivative of the function. In order to get the function, you have to make your equation equal to 0. So 4 times the sine of x plus 1 minus 3x equals 0. Once it's equal to 0, that is your function. We need to know the derivative of the function. So the derivative of sine of x is cos of x. The derivative of 1 is 0, and the derivative of minus 3x is minus 3. So in order to find my next guess for x2, for this solution to that equation, I plug into the formula. So x2 will equal x1, which is 1.5, minus the value of the function at 1.5. So 4 times sine of 1.5 plus 1 minus 3 times 1.5, divided by the value of the derivative when x is 1.5. So 4 times the cos of 1.5 minus 3. Again, we need our calculator to be in radian mode in order to calculate this. If you do it correctly, you should get a value of 1.6834. I'm going to get this accurate to 5 decimal places, so I will show it rounded off to 5 decimal places. However, when I use this new number in my Newton's formula, I will actually use the value on my calculator, not this one. I don't want to introduce error as I'm going through it, so be as exact as you can. Use the memory function on your calculator to store the actual number, and then recall that when you go through the process again. In order to find x3, I do this same calculation, but now I use the number that I have stored on my calculator instead of 1.5. Again, if you do it correctly, round it off to 5 decimal places, you should get 1.66143. And you know you're on the right track if the difference between your x values is getting smaller. So I went from 1.5 to this, then this to this. You can see that it appears that I'm converging to the actual root. We use the process again, and you will get x4 will be 1.66122. So again, very little difference. So you know that you're getting close. Do one more iteration or one more calculation now using this value, and you will get 1.66122 rounded off to 5 decimal places, which is equivalent to the value you got before that. So we know that this would be the root or the solution to that equation, accurate to 5 decimal places. Let's take a look at a related rates question. So we have a hot air balloon rising at a rate of 0.5 meters per second. We have an observer standing 50 meters away from the balloon, and we're asked how fast is the angle of elevation increasing 30 seconds after it takes off or after it lifts off. So the key that we know that we're working with related rates is it's asking how fast. So that's the rate of change with respect to time. Our first objective is to find a relationship between the angle and the height. So we'll make a little drawing. This distance here, this horizontal distance is 50 meters and it's not changing. The height is changing, and we're wanting to know the rate of change of the angle of elevation. So the angle of elevation is always between the horizontal and the line of sight. So I'm going to call that theta, and we want to know how fast that is changing. We know that the height is changing. It's increasing at a rate of 0.5 meters per second. We are given dh dt. We want to find the rate of change of the angle, so d theta dt, when h equals, well, we're not told what h equals, we're told 30 seconds later. However, if the balloon is rising at a rate of 0.5 meters per second, that means in 30 seconds, h will equal 30 times 0.5, which is 15 meters. So we want to find d theta dt when h is 15 meters. So we're going to come up with a relationship between theta and h, and that relationship is the tangent function. Now h is changing, so we don't put the 15 in until after we've differentiated. Theta is changing, so we leave it as a variable as well. So the only thing that wasn't changing was this horizontal distance of 50, so we put that value in. Now I could differentiate with the function as is, and I want to differentiate with respect to time. But because we want to find d theta dt, it will be easier if we isolate theta. So I could write this as theta will therefore equal inverse tan of h over 50. And now I could differentiate with respect to time. So d theta dt will equal, it's an inverse tan function, so the derivative will be 1 over 1 plus h over 50 squared, times the derivative of h over 50 with respect to time. So remember, h over 50 is like 1/50th times h. So the derivative will be 1/50th times the derivative of h with respect to time. Here's my rate of change of the angle with respect to time. Now I plug in 15 for h, and I plug in 0.5 for dh dt. When I evaluate this, I get 0.009, And my unit, I'm working with the rate of change of an angle. So my angle is in radians per, the time factor was per second. So this is how the angle of elevation is increasing at that particular height. Let's take a look at one more example, and this example is going to be a max-min question. So we're asked to find a maximum value of the function y equals 3 sine x plus 4 cos x. And the reason I say a maximum value is that with our trig functions, they're periodic functions, so there will often be, they will repeat themselves. So I'm just going to find the first point that is a maximum. In order to find maximum or minimum values of a function, I need to differentiate and set the derivative equal to 0 and solve. Then I need to test. So when we differentiate this, it will be 3 times cos of x plus 4 times the derivative of cos of x is minus sine of x. So that's the derivative. We set that equal to 0. And we solve this. So in order to solve this, I'm going to move this term over. So I'm going to have 4 sine x equals 3 cos of x. And then what I'm going to do is I'm going to divide both sides by cos of x. And I'm also going to divide both sides by 4. When I do that, I'm going to have sine x divided by cos of x equals 3/4. The reason I'm doing that is I can write sine of x over cos of x as tangent of x. In order to solve for x, I'm going to take the inverse tan of 0.75. Now, making sure your calculator is in radian mode because you want your answer in radians, we get a value of 0.64. Remember that there is another answer that would give us a tangent equal to 0.75, but that angle we're not going to worry about right now. We're going to just check to see if this is a maximum point. If it isn't a maximum point, then I would look at the other option. So we're going to test this. We're going to test whether this is a maximum point or not by testing the first derivative in this interval, finding the first derivative in that interval. And we're looking to see whether the first derivative is positive or negative. So in this interval, I'll choose 0. If I put a 0 in, cos of 0 is 1. So 3 times 1 is 3, minus sine of 0 is 0. So 3 minus 0 is positive. So that means the function is increasing in this interval. I'm going to choose a value I don't want to go too far with my value in this interval because we have to realize there was another solution and I don't want to go past that x value. So I'm going to choose 1, let x equal 1. And if I put 3 times the cos of 1 minus 4 times the sine of 1, I get a negative 1.74. So that means it's a negative. The function is decreasing. So therefore, this is a maximum. And the question just wanted to find a maximum value of the function. So that means I want to find, I've found where the function is maximum. I need to find what y is when x is that value. So in order to find the y value, when x is 0.64, and again, I'm going to use the actual value on my calculator, not the rounded off value that I wrote down. Even though I write it down rounded off, I'm using the value on my calculator. So I go 3 times the sine of that value plus 4 times the cos of that value. Calculator's in radian mode, and I get a y value of 5. So the maximum value, a maximum value of this function is 5. In the next video, I'm going to be moving on to finding the derivative of log functions. So when you're ready, I'll see you then. Take care.